Wednesday afternoon to you. This is the January 8th map discussion. We have a pretty busy talk right now because of this map right here. This is from the National Weather Service. This shows winter storm advisories, storm watches, and warnings from pretty much north central Texas, the Dallas-Fort Worth area, northeastward through the mid-south and into the southern parts of the Appalachian Mountains. Well, let's just look at the maps right fast. So here's our 300 millibar map. This is from the Storm Prediction Center. And shaded here is the wind speeds. So this is the top of the weather-producing atmosphere. And you'll notice that this little dip, this little kink here in the wind fields, this is our upper-level system that you can probably see a little bit better on the next map. But you'll notice in these yellow lines, this is where some upper-level divergence occurs. Now, divergence aloft induces convergence on the surface. And surface convergence pretty much is where low pressures are going to be associated. So notice that we have some divergence aloft, which is promoting convergence at the surface over the Baja of California at the upper levels. In the mid levels, we have a low pressure center that's completely cut off from the main flow, and you can see some of that enhanced flow across the southern plains into the mid-Atlantic regions. But at the 850 millibar level, that cyclone extends just above the surface. And what we're going to be watching is up here in the northwestern part, like pretty much in the Gulf of Mexico, just off the coast of Texas over the next several days, or over the next couple of days, for a surface low pressure center to develop. And those height falls, indicate where lift is being, synoptic scale lift is occurring. And notice that those height falls and the upper level divergence are overlapped. And so we have what we would call surface cyclone genesis occurring. That's your $1 million word. That just means that a low pressure is trying to form in the Baja of California, but it's not going to go all that. It's not going to be all that much. When this system swings across northern Mexico, this is when the upper level divergence and the height falls will be overlapped in the northwestern part of the Gulf of Mexico, and that's when the show begins. So here is our multi-model ensemble. This is what the model thinks or suggested that the weather map might look like. You can see the upper level low that is not completely cut off in this model run. It was in the analysis, so there's a difference there. And a surface cyclone starting to develop. Now, the evolution here is going to take us to tomorrow morning, and notice that surface low pressure is kind of weak going across that northern parts of Mexico. But notice that we have high pressure in the Ohio River Valley and another little low pressure center up towards the northern parts of Canada and Hudson Bay up there. And it's almost like a cold front or a boundary extending south into the upper Midwest or upper plains in the northern parts of the Mississippi River Valley. These two will kind of phase together somewhat. And as this upper level trough approaches the Gulf of Mexico, this is when we'll have those height falls and upper level divergence, which creates low level convergence and hence a surface low pressure center. Now, the track of this surface low pressure center is going to be critical, especially for north of that area where we'll see here in a moment, where a band of precipitation is forecast to develop. Somewhat north of that would be rain, and then rain changing to ice and eventually snow the further north you get. So and this is going to be very, very sensitive to the storm track. Any changes in the storm track would wreak havoc on the forecast itself. So, we're looking at an average of a couple of models and previous runs of those models. So, so we have this low pressure center in the southern parts of the Mississippi River Valley on the 10th, the morning of January 10th, 7 a.m. Eastern Time. By January 11th Eastern Time, those two low pressure centers are completely phased, and you'll have almost like a what we call a bomb cyclogenesis that occurs pretty regularly out here towards Cape Hatteras. And this is expected to go off the coast, and not necessarily up the coast, but off the coast of New England, while high pressure becomes dominant feature over the Carolinas. Another little low pressure center develops in the Red River Valley, and nothing really is coming of that. In fact, previous model runs had another surface cyclone developing in the northwestern Gulf of Mexico, but it looks like this system is going to be pushed too far to the south. I mean, look how south that high pressure center is, and look how strong it is on the January 14th and the 15th. That high pressure center is settling in over the southern plains. And the other thing that we need to mention is over here in California, you see these very tight pressure gradients out here. There's a critical fire weather out there, and this is because of those winds and the high pressure that is over the Intermountain West. So, folks out in California also need to be aware that there's a critical fire danger, not only today, but possibly into next week as well. So now looking at our multi-model ensemble precipitation, surface pressure, and surface temperature, we can kind of get a sense of how this storm is going to evolve. So right now, our surface low is over here in the northwestern parts of Mexico, over the Baja of California. And as we push this forward, by tomorrow afternoon, we should start to see a developing surface low across the northern parts or northwestern parts of the Gulf of Mexico. Now, this precipitation is forecast to expand northward pretty quickly as it phases in with the low pressure center in southern Canada. And what we're looking at here is, again, our multi-model ensemble with the National Blend of Models precipitation. And it's forecasting a pretty northward expanse of their precipitation. The solid blue line is our 0 degree or 0 degrees Celsius surface temperature. So anything north of that or along it would be categorized as wintry type of precipitation, whether it's snow, sleet, or freezing rain. Anything south of that would be rain. So a very cold rain in southern parts of Arkansas into Mississippi. But notice that when we go forward into Friday afternoon, some precipitation will start to overspread western North Carolina and South Carolina and Tennessee, while temperatures are above freezing. But it's so dry that when it really starts to come down, temperatures will quickly fall below freezing, and everything would turn to some sort of wintry precipitation by 7 p.m. Friday evening. You're looking at some pretty hefty precipitation amounts across parts of the southern Appalachian Mountains into the deep south. So this looks like a very nice winter weather system that will be affecting parts of the Ohio River Valley, Tennessee River Valley, and southern Appalachians, especially across North Carolina and eastern Tennessee and points northward. And then even some pretty hefty snow totals in parts of eastern Kentucky and western West Virginia and Virginia. But as this system is forecast to move off the coast, not really affecting the southern New England, which might still occur. This cyclone might scoot up the coast, and if it does, it tends to become what we call a nor'easter. So a pretty good snowstorm for those folks up in the northeast. But that's not forecast right now. As we get into early next week and into the midweek, we're expecting high pressure to remain in control. Maybe a little clipper system, bringing some lake effect snow across the lake effect prone areas, while a very cold high pressure center starts to slide into the upper plains, the northern plains and northern Mississippi River Valley. That surface low response in the Gulf of Mexico looks like it's going to be too far south for any other winter storm to form. This is the Global Ensemble Forecasting System, courtesy of the College of DuPage Next Lab website that I will be referencing in the description of this video. But this shows you the different members. So I'm going to push this forward and highlight a couple of things that are pretty interesting as far as weather modeling goes. So note, so this is Friday morning. Some of the members have snow creeping into the southwestern mountains of North Carolina as early as 7 a.m. Friday morning, while the vast majority of the members do not. This is a timing issue of when precipitation will start. By Friday afternoon, some of the members have snow beginning to fall in the Charlotte region, and some of them do not. So again, timing issue. The other issue is, take for instance member 10 here. It has some ice in the northern upstate of South Carolina and southern Piedmont and foothills of North Carolina, while this member hardly has any ice. So this is indicative of some members having what we would call a warm nose, i.e. member 10, member 9, 8, 7, perhaps 1, 3, 4 and 5, 11, 12, 13, 20, maybe 19 could be argued, but 16, 17, and 18. Some of those members have what we would call a warm nose. And a warm nose is a pretty funny term for warm air aloft. So as snow falls into this warm layer right above the surface of the earth, it melts, and then it falls into a sub-freezing layer below it as either sleet or freezing rain. And that's what this purple is either sleet or freezing rain. So some of the members have a warm nose, and some of them do not. And why is that important? This is important because this has a tremendous effect on snowfall totals. Because sleet and freezing rain isn't snow, the models will not accumulate snow if it's producing sleet or freezing rain. Now you can write an algorithm where, okay, you can count sleet, but we're not doing it here. So the more of a warm nose that is present in the atmosphere, the less snow is going to accumulate, and the more ice is going to accumulate, We do not like ice. We would prefer snow if we were going to get anything. But this is a very important aspect of this system. Now, 9 times out of 10, when you have a setup like this, a synoptic setup where you have surface low pressure in the northern Gulf of Mexico, and it's going to be riding along the northern Gulf of Mexico into the Atlantic and up the coast, typically you're going to have a warm nose. And the closer the surface low is to you, the more prominent that warm nose will be. And if you're south of it or along it, the surface temperature is going to be above freezing. So, whatever. If you're south or if you're north of the surface low and it's pretty close to you, you're going to have a pretty good warm nose. Like, for instance, take member 7 here. The surface low is located just south of Columbia, and there's a huge warm nose with sub-freezing surface temperatures in pretty much North and South Carolina and into Georgia and southeastern parts of Virginia. Which means that member 7 might not be predicting a lot of snow. But member 19 would be predicting a lot of snow. So this is another aspect of why I'm not really comfortable right now looking at accumulations because of this warm nose feature. If we look at another model that is historically better at the warm nose, which is the NAM. The NAM, especially in North and South Carolina, the NAM is historically been better at handling the warm nose than the GEFS. Is some influence of the GEFS in our multi-model ensemble. There's no NAM influence in it, although we could easily incorporate the NAM, but we are not right now. If we go forward, here we're looking at precipitation type and thicknesses. This thick purple line is the traditional rain snow line, which you will see that it is not traditional in this storm. Anything above that is typically wintry type precipitation. Anything south of that is typically rain. If we push this forward, you can see some ice and sleet on the southern parts of the snow shield, indicative of a warm nose. Now, this warm nose is expected, according to the NAM, to be very prominent as that surface low tracks across southern Georgia and up through the South Carolina coast from Savannah to Wilmington, North Carolina, and up towards Cape Hatteras by Saturday morning. So, according to the NAM, this warm nose is going to cut into the snowfall accumulations. So, places like Charlotte, up towards Hickory and Boone, we'll start to see snow late afternoon on Friday, but then change to freezing rain and sleet by Friday evening, and pretty much end as sleet or freezing rain. So it looks like, according to the NAM, like places like the upstate of South Carolina and the Charlotte metro region, all the way north up pretty much just south of the border between Virginia and North Carolina, is going to be more of an ice storm than a snowstorm. And typically, that happens because of that warm nose. So another feature that we have to look out for is that warm nose and the eventual track of the surface low. Any deviation in the forecast between those two will have a tremendous amount of impact on snowfall totals, especially across parts of western North Carolina and the upstate of South Carolina. Whether or not we're dealing with snow or sleet or freezing rain, some very impactful weather could be felt across anywhere from north central Texas across the mid-south into the Ohio River Valley, western North and South Carolina, northern parts of Georgia, Alabama, perhaps Mississippi, and into southern New England and the Mid-Atlantic. Winter storm watches and warnings have already been posted by the National Weather Service. Please take any precautions because some power outages are likely, especially areas where you get more ice than snow. And in this particular satellite image, you can see the snow of the previous storm system across Kansas, the majority of Missouri, southern parts of Illinois and Indiana, and some clouds are obscuring Kentucky, but nonetheless, there's probably snow some parts there too. This will probably fill in a little bit more south with this next storm, so we'll be able to see that progress. But anyways, thank you for watching. I will probably post another video, a special video, tomorrow afternoon or evening, updating and possibly giving some preliminary accumulation forecasts from the model output. So thank you guys for watching, and be safe out there, and I'll see you in the next video.